day. So before we were just looking at how to take the percent of a number, and now we're going to say if I start with something and change it by a certain percent, what do I end with, or so on and so forth. So the first thing we need to do is define some terms. So I'm going to draw a tape diagram here. And anytime we draw a tape diagram, remember we label 100%. Now when we have this tape diagram, it can change. Either it can get bigger or smaller. So I like to say that we always start at 100, right? When you wake up in the morning, maybe you don't start at 100, but we're going to pretend that you do. And we're going to say we're going to start at 100. So this is where we start. So we could call it the original. We could call it the start. We could call it the whole. There are all sorts of terms that we use for it, but that's where we start, okay? And then throughout the day, you either get increase or decrease. Okay, so we're going to say if you increase, this is your ending percent. So maybe you end better than you started the day. Okay, and we would call this we could call this the new, we could call this the end, we could call this the part. Those are all different words that we use for that. Okay, so sometimes this would be an increase. So we're going to call that a percent increase. And what we're going to think about is we always start with 100%, we end with some other percent, and then we figure out what did we add, some percent increase we added here. Okay, so that's oftentimes what we're looking for, is that actual number, that's the percent increase. And we'll look at some examples here in a minute. What if we had a decrease? So here's our tape diagram. Again, 100%. We start at 100%, but then what happens if we have one of those days where we decrease? Then we're going to still end. We're going to still have an ending percent. We can still call this the new, the end, the part. See how it doesn't really matter if it's on the left side of the tape diagram or the right side of the tape diagram. Basically, we always start at 100. So 100 is where we start, and then we either go up or down from there. We call this the original, the start, or the whole. Those are all different ways we can say that. And then this would be a percent decrease, because we lost, right? That would be percent decrease. So let's see how this actually works in some problems. We also need to be able to set up a proportion to be able to solve some of these, okay? So we've done a proportion before, and we did part over whole equals percent over 100, so I'll write that. So now we can use some other words, same thing, right? I could say new over original equals my ending percent over 100. It's the same thing, remember, because the new and the part are the same thing, the original and the whole are the same thing. This is how we can set up any of these problems. And the cool thing about this is if we know one of them, or if we know two of them, we can solve for the third. Okay, so let's take a look at some problems. First examples we're going to look at are finding the new amount. So you're going to get the old amount, you're going to get the original amount, and you need to figure out the new amount. Okay? So we look at, let's see, if something cost $99.50 and it had a markup of 95%, so this means this is how much the store paid for it, is $99.50, and they marked it up 95%. So the first thing we need to do is draw a tape diagram. And since this is a markup, we're going to do a percent increase. So you always just draw your tape diagram, label 100, and then go ahead and draw it as an increase or a decrease, okay? So this is an increase, and we know that the increase was 95%. So we can ask ourselves, if I started at 100% and I added 95%, well, I'd end at 195%. And then what did I start with? Well, I started with $99.50, and I don't know where I'm going to end. They did not tell me my ending amount, so we can call that X. So all we have to do is solve for it. We're going to set up our proportion. We do our new over original. We don't know the new, so we're going to call that X. but we do know our original is 99.5 or 99.50, and we know our new percent that we want is 195%. So then remember, all we do is cross multiply. So I'll write that out this one time, but I won't write it out on every one. So we do 99.50 times 195 equals 100 times x. So we cross multiply. When we multiply 99.50 times 195, we get 19,402.50 equals 100x. We have to divide both sides by 100, and we get 194. Oh, I ran out of room. 194.025. Now, since this is a cost thing, we need to write this as money. So that would turn into $194.03. That's how much they would end up selling this for. Now, what if we are looking at a markdown? So again, we're still given the original and we're given the increase or decrease percent, but now we're looking at it going down instead of up. So we're going to do the same thing. We have a $3.95 item and they're going to mark it down 20%. Maybe it's on sale. So we're going to draw our tape diagram. We always start with 100. And then this is a markdown, so I always start by drawing my tape diagram as a markup or markdown. And I find my new percent if I can, right? So 100 minus 20% would give me 80%. Then I ask myself, where did I start? Well, I started here with 395, and I always start at 100. Every day I start at 100, so I put that at 100. And then I do not know my ending, right? So that's what my unknown. So we'll go ahead and set this up. We don't know the new. We know the original is 395. We know the new percent is 80 over 100. Okay, then we cross multiply and divide. So we do 395 times 80, and that gives us 316. We do 100 times x, which gives us 100x. So we have to divide by that 100 that was left over, and we will get $3.16. And since this is already rounded like money should be, that would be our answer. And then it'll, since it's money, we should probably put the dollar sign. But there we go. All right, now we're going to be finding the original. I made a little mistake there, so I put that original. Okay, finding the original. So this is where we're given the new and the markup or markdown, but we don't know the original amount where we started. So again, we're just going to draw a tape diagram. This helps us visualize what we're actually doing. Okay, so we start at 100 no matter what. Even if we're doing finding the original, finding the new, no matter what, we always just draw our tape diagram, put 100. Okay, and then it says there was a markup. Okay, so we always draw this as a markup. And there was a 15% markup. Okay. And we know that from 100% to plus 15, we would go to 115%. And now it says the new price was $7.94. So new goes here because we say this is where I start. I always start at 100. And the new price was $7.94. I don't know what the original price was. Okay? So setting this up just helps us so that we can visualize what exactly we're looking for. So we're going to set up our proportion just the same as always. Okay? We're going to call the new price, since it's new over original, we put the new on top, original on bottom, and our percent is 115. Okay, and then again, we're just going to cross multiply and divide. So in this case, we're going to have 115 times x equals 794 times 100 is 794. So then we just need to divide both sides by 115. And we get that x equals 6.90. And if you look at the calculator, we get these really strange numbers. But see how there's a 4 next? So we're just going to round, and since the 4 is less than 5, we don't round that up. So we're just going to do 690. So this originally cost $6.90. They marked it up 15% and ended at $7.94. Let's look at one more example. Okay, if the new price was $11.51 and there was a 4% markdown, what is the original price? Okay, so again, we're going to just draw this tape diagram. I know it probably gets a little tedious drawing these, but the thing is that it's really difficult to visualize otherwise, even for me as a math teacher. Okay, so we look at this and we say, oh, it was a markdown. So I'm going to do a markdown, and I'm going to make a big one, even though I know 4% isn't very much, just because I like to have a little space. So I went down 4%. So if I start at 100, go down 4%, I end at 96%. Okay, I don't know the original. Now this is where it gets tricky, is sometimes up here, see, the original was on the left, and this time the original is actually on the right, because remember, the original is always 100, right? We start at 100, and then we either go up or down. We never start anywhere else, okay? So we started at 100, and we didn't know where we started, but we know we ended at 11.51, okay? So we're going to do our proportion here. That goes on, let's see, new over original, and original is what we don't know. So we'll go ahead and do that cross multiplication. We did 96x equals 11.51, divide by 96. And we get x equals 11, and it goes 9895. And some more numbers, if you can see that. So we're just going to round this. So we go to 98, and we look at the next one. This is a 9, so it's bigger than 5, so we round up. So we do 1199. So this was originally 1199. Now we're going to find the percent change. So in this case, we were given, the last ones we were given what the percent change was, and we either had new or old. Now we're just going to have two. We have the new and the old, but we don't know how much it changed. So again, we're just going to draw our tape diagram. Oh, and I forgot to give you the problem. So we're going to find the percent change from 82 to 38. So we could call this dollars, pounds, whatever we want to call it, but really this is saying we're starting at 82 and we're ending at 38. So we know that that's a markdown or a decrease, because 82 is bigger than 38. Okay, so we're going to just draw it like that. And we know that we started at 82, and we always start at 100, and we ended at 38. And we just didn't know what this percent was. Okay, so we just set up our proportion again. So we've got new over original equals percent over 100. We cross multiply and divide. We get 3,800 equals 82x. Divide by 82. And we get x equals 46.34, and then some more, so we're going to just round to the second. It was 341, so we don't round up. So we found our percent, right? So that goes here. 46.34% is where we ended, but we didn't ask where we ended. What we asked is, what is our percent change? So the question is, if I started at 100 and I ended at 46.34, what did I actually change? So you have to take that and you have to subtract. To find the percent change, you have to say 100 minus 46.34, and you get 53.66. So the actual change here, the actual change is 53.66%, because we didn't change by 46.34. We ended there. So we have to figure out what's the difference between 100 and 46.34. Oh, and one thing I forgot to do here is that we need to say this is a decrease. So if it's finding the percent change, you do have to say whether it's an increase or a decrease. So we had a 53.66% decrease. All right, so now let's find the percent change from 75 to 45. So again, we're going to draw our tape diagram. And this is a decrease because 75 is bigger than 45, so we're going to draw this as a decrease. So we started at 75, we ended at 45, but we don't know the percent, so we're going to set up our proportion. New over original equals percent over 100. When we cross multiply, we get 4,500 equals 75x. Divide that by 75, and we get 60. Okay, so remember, that's not the answer. That's where we ended. All we were finding here, this is the end. Okay, we have to decide what was the actual change. So if the end, we went from 100% to 60%, how much did we actually change? So our change in this case is 40%. We actually really changed 40%. And again, we have to write whether it's an increase or decrease. In this case, it is also a decrease. Whoop, off the page. There you go. Last examples, we're going to actually write some equations, and this really just builds on these proportions. The nice thing about these equations is just that they make it a little bit more efficient if you start getting used to being able to do these equations. So the first one says the value of x is decreased by 5%. So x is decreased by 5%. Write an equation that represents the situation. Okay, so again, we're going to draw our tape diagram. We always start at 100, and we always start with x, and we end with y. Okay, so x is always our starting, and y is always our ending. So this is a decrease, so I'm going to draw it as a decrease. And so we started at x and we end with y. Because in this case, they didn't actually give us any numbers to calculate. All they did is said, write an equation that you could use for any number, right? So we know that it decreases by 5%. So what percent are we ending at? We're ending at 95%. Okay, and so then this is how we can write this equation. So we start by setting up our proportion. And we've done it this way 100 times, right? New over original equals percent over 100. But if we did this, our equation is going to look a little funny. It's not quite what we want. And so instead of writing these as percents, we can write these as decimals. Because remember, 95%, we could write this as 95%, is the same as 0.95 as a decimal. So I could just rewrite this whole thing as y over x equals, and in this case we're going to write it as a decimal, 0.95, and 100% as a decimal, you could think of it as 1.00, or really we can just think of it as 1. Okay, so now we're going to do our cross multiply and divide. We do x times 0.95, and we get 0.95x equals, and we do y times 1, okay, so 1 times y. But now if we did the divide, we would be dividing by 1, and when you divide by 1, it stays the same, right? So we don't actually need that 1. We don't actually need to divide at all here. This just can be written now as 0.95x equals y, and then we're done. That's all. So this is an equation which is really nice because we can say if x is our original values, and y is always our new values, you could say if I have a new value, I just plug it in for y and solve for x. If I have an original value, I just plug it in for x and solve for y. And we could do that in a table, all sorts of other ways. We'll show that in the next example. Okay, what if x is increased by 215%? Okay, so again, we're going to draw our tape diagram. And we're going to think of this as an increase. So we're going to go ahead and do this. Increase of 215%. Remember, that doesn't mean we end at 215%. That means we add 215%. So where do we actually end? Well, we actually end at 315%. Now we're going to call our starting value x and our ending value y, okay? Because x is always our starting. y is always our ending. Now we just need to write an equation. Again, we can set up this proportion, and we can say y over x equals, now again, we're going to write this as a decimal instead. So instead of 315%, remember we moved the decimal place twice, and this is actually 3.15. And 100% as a decimal is just 1. Okay? When we cross multiply and divide, we get 3.15x equals y, because remember 1 times y is just y. And there we go. That's your equation. You are actually done. And what you might notice is you might actually not have to do all this rigmarole every time, because you can see that all you need to do is take your ending percent, turn it into a decimal, and multiply it by your original. To find the percent of any number, that's all you have to do. Take the percent you want, turn it into a decimal, and multiply it by the number, the original number, and you'll get the new value. So we'll use this to solve just one problem. So what if I said I had a new value of 2,205. Okay, so I could make a table here, and I could do an x and a y, and I could say my new value is 2,205. What is my original value? So there's a couple ways, if you remember with tables. Basically what we're saying is I take all of these x values and I multiply them by 3.15. So I could think about this as, well, if I multiply this way, I divide this way. So that's one way to do it. We could take 2,205 and divide by 3.15. Or we could put this into our equation, and we could say, all right, so we know that 3.15x equals y. And in this case, we have a y value of 2,205. And to solve this equation, what we're going to do, I'm going to divide by 3.15. And in the end, we divide by 3.15, we get 700. And do you see how we divided by 3.15 here, we divided by 3.15 here? Either way we use this equation, we actually can find a value, right? So we would say if we started with 700 and had a 215% markup, we would end with 2,205.